Okay, so a couple more examples just to make sure that you do understand. There's actually an example on here that we didn't quite do yesterday, so you could see what happens if you get a certain type of answer. Um, so same steps, same equation, same process. Let's just practice a little bit more. All right, so remember from yesterday, this is B, B, A, C, A. Oops, I don't know why I did that. Okay. Step one, we're going to identify A, B, and C. Step two, we're going to plug in. Step three, we're going to solve for X. Okay, so let's start with step one, A, B, C. It's already in standard form because all my terms are all on the same side of the equal sign. So A is 8, B is 6, C is 1. Alright, so step 1 done. Step 2, let's start plugging them in. I have negative B is 6 plus or minus the square root of 6 squared minus 4 times A is 8 times C is 1. All of that is divided by 2 times A. Alright, step 2 is done. We plugged all those numbers in where they belong. Step 3, this is where I get to start solving. So I have negative 6 plus or minus the square root of 36 minus, what is that, 32, yeah, 32, okay, divided by 16, okay. So x equals negative 6 plus or minus square root of 4 over 16. Alright, let's keep going. So now I have x equals negative 6 plus or minus 2 over 16. Alright, so this is where I get to split it up into my two answers. One of them when I'm adding the two, and the second one when I am subtracting the two. So this is going to become negative 4 over 16. This is going to become negative 8 over 16. This gets simplified to negative 1/4. And this guy over here gets simplified to negative 1/2. Okay, another one. Same steps, different numbers. Same steps, different numbers. Alright, let me fill in my equation here. Those numbers never change places. They're always in the same place. Alright, 2, negative 8, and negative 13. Alright, A, B, and C. Alright, let's go ahead and start plugging them in. Hopefully by now you got the hang of it. Negative 8 plus or minus the square root of negative 8 squared minus 4 times 2 times negative 13 all divided by 2 times 2. Alright, step 2 is done. Now I get to start solving. 8 squared is 64. Negative, so look what's going to happen here. Negative and a negative. Those two negatives are going to make this plus. Okay, those two negatives make it a plus. Okay, now 4 times 2 is 8. And then 8 times 13. 8 times 13, 8 times 13. I don't know off the top of my head. Let's see. 8 times 13, 104. Okay, divided by 4. Alright, so let's keep going. 8 plus or minus the square root of 168 over 4. And I don't think that's a perfect square, but let me check with my calculator. Square root of 168. Alright, it's not. Okay. So this is what happens when we don't have a perfect square. Okay, what you have to do is, instead of getting a nice whole number, you're just going to simplify. Okay, as much as you can, you're going to simplify that radical. Okay, again, this is not an Algebra 2 thing. You should have probably done this in Algebra 1. It's been a little while. Okay, but what you want to do is you want to think of what numbers here. So you're like kind of like factoring, I guess, if you want to call it factoring. I don't know. Numbers here that would multiply to get 168, and one of them, it would be preferable if one of them was in fact a perfect square. So like 4 is a perfect square. Let's see if we can multiply 4 times a number to get 168. Let's check. Okay, yeah, 42 works. Okay, so 42. 4 times 42 is 168, and 4 is a perfect square. And then you have to ask yourself, can you break 42 down even more? And unfortunately, I don't think you can. 42 divided by... Nope. You can't. I mean, you can divide 42 by 2, but 2 is not a perfect square. So you want to try to break it up into perfect squares to get as simple as possible. Alright, so now that we've broken that up as far as we can, let's go back to our equation. So we have... I'm just going to rewrite this as the square root of 4 times 42. Okay, so we know that 4 is the perfect square, which is fine. 4 can come out. Square root of 4 is 2. 42 is not a perfect square. I can't break that up anymore, so I'm just going to leave it as is. Alright, and then this is where I'm going to break it up into my 2 possible answer choices. One of them when I am adding, and then the second one when I am subtracting. So this is definitely not going to be a very pretty answer like we've been getting. Okay, now again, I'm just simplifying. I'm trying to make that ugly equation as small as possible. So if I notice here, 8, 2, and 4, I can divide all those numbers by something. The smallest number I can divide all those numbers by is 2. So if I do that, I end up with 4 plus or minus the square root of 42 over 2. That's one answer. Same thing happens to the other side, but instead of adding, I guess I should have left this one as plus. Instead of adding, I'm just going to be subtracting here. I guess because they're exactly the same, you could probably leave it as plus or minus and that would still be okay. Alright, so that really just means it's some decimal value that I have no idea what it is off the top of my head. And I do not want you to find that decimal value. I want you to leave it as this rational expression here. Okay, so I do not want you to find that decimal value. Just leave it as is. Let's get comfortable with being uncomfortable. Okay, one more question. So here, I'm going to change one thing up. I'm going to make this a plus. Let's make this a plus 6, because that's going to change our answer a little bit. And I want you to see a situation when this happens. Okay, so let's go ahead and start. Alright, B, B, A, C, A. Okay, so same steps. Identify your A, B, and C values. A is 2. B is -4. C, we changed it to 6, positive. Okay, we changed it on purpose. I'm purposely changing it because I want us to see something. If we leave it as -6, we're going to get answers, which is fine. but I want you to see a different kind of situation. All right, so let's go ahead and plug it in. We have -4 plus or minus the square root of -4 minus 4 times a is 2 times c is 6 divided by 2 times a. Alright, I plugged it in. Now it's time to start solving. It's going to be 16 minus 4 times 2 is 8. 8 times 6 is 48. Okay. Keep going. So I have 4 plus or minus the square root of -32 over 4. Alright, this is the part that we haven't done. Right, just like we did this part right here, we hadn't done one like that. We haven't done one like this. We haven't done one where we get a negative underneath the radical. If we would have gotten positive, or whatever it was, I don't even know, we probably could have gotten an answer. This is still an answer. Okay, that's, even though it doesn't look pretty, it's still an answer. But what happens when we try to get negative? Even if it was a perfect square, that's not going to work. Your calculator is going to tell you that there's an error. Okay, so what happens actually, we actually call it imaginary. When there's a negative underneath the radical, we call it imaginary. But we're not going to talk about that right now. We're talking about just real roots. This is not real. This doesn't work. Okay, I'm going to put that back. You cannot like have a negative in the radical. It doesn't work. It's just not, nope. Okay, so when this stuff happens, that means that we have no solution. Okay, now I don't know what this particular graph looks like specifically off the top of my head. Could I find it? Sure. But what it means graphically is whenever we get no solution answers algebraically, what it means is that there's something like this happening. It doesn't matter if it's pointing up or pointing down. Anytime I get no solution, that's because my function never came into contact with my x-axis. Okay, so if you have a negative in the radical, automatically stop. You don't have to keep going. No solution.